All right, so we're going to take a brief break from our series on non-linearities within linear regression to talk about dummy variables. Now, we're going to get into dummy variables a lot more after this upcoming midterm, but it's important that we go ahead and get some sort of a working knowledge of dummy variables and what exactly they do. Okay, so dummy variable, it's a binary variable. Okay, so binary, that just means that it's going to take on a value of 0 or 1. Okay, now an example that we've seen earlier in this course of a dummy variable, we just didn't call it that, was female. Okay, so female, this variable female, is 1 if and only if the observation. Okay, so let's assume this is some sort of individual level data and these observations are representing individual people. So this observation is a female individual. Okay? Now, don't want to offend anyone, but let's assume for making this an easy problem that we have two possibilities. We have female and male. Okay, so let's just assume we've only got 4 observations, so let's assume good chance in this 4 that this is how people identify. So let's assume that the first two are female. Okay, are male. Okay, so for the female category, these first two, since they're going to be male, they're not going to be female. Okay, so our definition up here said they're going to be 1 if and only if that the observation is a female. So in this case, they're not a female, so they're going to be 0. Okay, we said they were males, so they're gonna be a very similar thing. They're going to be 1 because they are male. The next two observations, though, let's say that they are female, and so they're going to get 1. If they're female, that means they're not male, and so male is going to get 0. Okay. Now, what's important to remember here is MLR3. Okay, remember we made a bunch of assumptions, and MLR3, and this is a complete paraphrasing on my part, but MLR3, we said not only must there be variation in X, but there must also be variation between all linear combinations of X. Okay, so if we combine, we take the linear combination, if we combine female and male, so let's make a new column here called total, and we add female, let's see here, female plus male, we're going to get 1. Add female plus male, we're going to get 1. Add female plus male, we're going to get 1. And we're going to get 1. Okay, so there is no variation on this linear combination of male and female, so we can't do this. It's not going to mathematically work. So we have to omit one of them, but that's okay. We can actually figure out the values for male and the values for female, how much the effect of being male or effect of being female are, and we don't need to include both of them, thankfully. Okay, So in order to do that, I'm going to show you, this is an example from class, or excuse me, rather from our textbook. Let's make this a little bigger. All right, so this is our example from our Wooldridge text. And you may, if you can look at the top here, you can see what we're running. We're running a regression to see how female and education affect wage. So wage is our y variable. Here, the Wooldridge uses deltas to notate coefficients for dummy variables. I don't typically do that, but just if you see it when you're reading the book, that's what's going on. Is this delta 0 is just representing the coefficient for dummy variable of female. Okay, so this particular graph is just graphing the relationship between education and wages for females and males. So let me explain kind of what's going on here. Let's assume that we live in a world where we're just looking for the effect of of education on wage for males. Okay, if we're looking for the effect of education on wage strictly for males, then this female category here, this female dummy, it's going to equal 0. Okay, and if this equals 0, then this whole term is going to be equal to 0. Okay, so if this whole term is equal to 0, I'm just going to scratch through this, and we've just got, if we've run a regression, we've just got, excuse me, let me put this in the right place. Then we've just got wage hat equals beta 0 hat plus beta 1 hat times education. Okay, and that's all that we're graphing here on this particular line. Okay, but now let's assume that instead of looking for the effect for men, let's assume we're looking the effect for women. Okay, so now this female variable is going to be equal to 1 all the time. So if it's equal to 1, then just this part is just delta. It's going to be delta 0 times 1, right? So we've got these two constants, beta 0 plus delta 0. Okay, so this is basically our new constant for women. So in this particular case, it's commonly seen that women make less for this same job, the same education, than when compared to a man. So we would expect maybe that this delta 0, we expect that is less than 0. Okay, so if it's less than 0, what we're going to see is we're going to see the intercept shift down by this amount of delta 0. Okay, so this combination of beta 0 and delta 0, okay, that's going to give us a new intercept right here. Okay, so this new line, this is representing the relationship between education and wages for women. Okay. All right. So that's the basics on dummy variables. I'm going to go a little bit further, and I'm going to note that there might be something that has multiple categories. Okay. So for gender, we saw it had two different variables we could have made with it, male or female. We chose to omit male, and we chose to put female in. But what if there's a lot more? Okay, so what if we're working with, for example, the car data set, so the auto data set that we've been using, and let's say that we're looking at who's making these cars, and we might see something like, well, we might see Toyota. Toyota. We might see, Ford, Chevy. I don't think Kia's in there, but we'll just make Kia up. And so let's say BMW. Okay, so we've got these different categories that we could possibly be in, and it's more than just two, more than just male or female. We've got multiple categories now. So how can we deal with this? Well, if we wanted to see the effect of make on something like price, for example, then we could just turn this into a series of dummy variables. Okay, so for example, I could have a variable called Toyota. I could have one called Ford. I could have one called Chevy, one called Kia, and one called BMW. Okay, and if they equal one if and only if their title is the type of car, so we would have 1, 1, 1, 1, 1, and then zeros the rest of the way. Okay. And the key here again, just like we saw with male or female, we can't have any sort of linear combination that doesn't vary. So if we combined all of these, we'd have 1, 1, 1, 1, 1. Okay, so they're all the same once we combine them all. There's no variation here. So we can't do that. We've got to omit one of them. Again, just like we saw here, this is really just going to be an intercept shifter. So here, min were the base category. Okay, base category meaning that's what beta 0 represented. That was our omitted category. And here it would be the same thing. So for example, if for example we omitted Toyota from our regression. So let's say we've got some regression price is equal to beta 0 plus beta 1. Let's say Ford, so we're going to omit Toyota, plus beta 2, Chevy, plus beta 3, Kia, and beta 4, BMW. Okay, so for this case, we would be omitting Toyota, and Toyota would be our base category. Okay, in other words, that is what beta 0 is kind of taking on. So let's kind of prove that in action. If I'm interested in the effect of the brand on price, just in general, and in particular, I wanted to see Toyota. Okay, so I want to see what's the effect of being Toyota on the price. What I could do is I could say, well, it's not a BMW, it's not a Kia, it's not a Chevy, it's not a Ford. Okay, so all those things are gonna values would be 0. So this entire thing would be 0. So we're just left with beta 0. Okay, so if my vehicle's a Toyota, then my price on average is going to be beta 0. Okay. However, let's assume instead that we've got, let's say, a BMW this time. So if it's a BMW, then Kia is going to be 0, Chevy's going to be 0, Ford's going to be 0, so these are all going to be 0. Okay, and BMW, this is going to be equal to 1. Okay, so our price in this case is going to equal beta 0 plus beta 4. Okay, so this combination is going to be our new intercept if we're talking about BMWs specifically. Okay, so it's whatever's in excess of Toyota, and of course this could be positive or negative. That is going to be pretty much the basics of dummy variables. If you want to make this a little bit easier to do when you're going to do your homework, I'm going to give you one last bit of advice for Stata. So if we want to create a dummy variable, there's multiple ways to do it. I think the easiest way is to use parentheses when we're using the generate function. So for example, if all I wanted was a dummy variable for Toyota, okay, that's all I wanted. I didn't want to make all these others for whatever reason. Then what I could do is I could generate a new variable called Toyota. And I could say that equals 1. Actually, you know what? There's an easier way to do this. I could say that, put this in parentheses, like I said, and I could say, well, if make, which is this variable, if that equals Toyota, I'm going to put this in quotation marks because it's a string. Okay, so basically I've made a logical statement within parentheses here. Then this would actually be all I needed to generate a new variable that was Toyota. That was 1 if and only if the make was equal to Toyota. Okay, but if I wanted to keep all these, if I wanted Toyota, Ford, Chevy, Kia, BMW, if I wanted to run that in Stata and I didn't want to generate any variables, go through the trouble of doing that, there's actually an easier way. So, for example, if I wanted to regress, let's say price, on whatever the make is, then I could just say I dot make. Okay, and that I is basically standing for like an indicator variable, or also known as a factor variable. It's creating these indicators for if I'm a Toyota, Ford, Chevy, Kia, and BMW. And it's not actually creating it and putting it in our data set permanently. It's just doing it temporarily for this. So we don't have to go through the trouble of actually generating any new variables if we didn't want to. We can just put I dot before it, and it's going to generate when we run the regression dummies for all of these, and it's going to automatically omit 1. Okay, so that's something pretty neat that Stata can do. Okay, so that's going to be pretty much it for this introduction on dummy variables. There's a lot more things we can do with dummy variables, and we're going to talk about dummy variables a little bit more in the next lecture, which is going to be continuing on talking about nonlinearities with linear models. In particular, we're going to talk about interactions between variables. Okay, so we're going to use dummy variables within that lecture. Okay, all right. So thank you very much, and we'll see you then.